All right, greetings, you insanely brilliant AP Environmental Science students. We're going to talk about topic 6.9, 610, 611, which is geothermal, hydropower, and hydrogen fuel. All right, so just remember to do our reading. I know a lot of you guys try to ignore that resource, but there are going to be details that I don't bring up explicitly that you get from that. Let's utilize all these resources available for more comprehensive access to this information. All right, so we're going to start with topic 6.9, which is hydropower, something in our region here in the beautiful Pacific Northwest that we ought to be quite familiar with. So the concept of hydropower is not a new one. All right, the basic idea. Now, this is not the only form that hydropower takes. Mind you, we'll get to that shortly, but traditional hydropower in the United States, right? We build a big concrete structure across a river, refer to those as dams. Behind that dam, we build, water builds up into a big reservoir. And what that does, okay, aside from allowing for some flood control and water storage for irrigation and even some recreation, right? What it does in terms of hydropower is creates an enormous amount of gravitational potential energy. So in other words, we have this huge mass of water behind the dam, right? And that dam is strong enough to hold that water, but we do have these openings we refer to as penstocks that go through the dam, right? So all this water behind that giant reservoir is pushing extremely hard, right? And once that control gate opens, water can flow really quickly. That flowing water has a lot of kinetic energy now that can be transferred to a turbine. So a turbine, remember, we think that it's just like a big fan or a big water wheel in this case, right? That spins the generator, that feeds electrons out to the grid, and we have electricity. Okay? So not a super high tech concept, right? So there are some major advantages to hydropower. One of them being that it is very efficient of all of our energy forms for electricity. The direct transfer of what's the amount of energy in the reservoir to how much becomes electricity. It can be up to 90% efficient. Okay. Now, we also have that 24/7 capacity, right? So unlike solar and wind, which are intermittent sources, hydropower can be used at any time of day, regardless of the weather. Now, it is, of course, somewhat limited by the water cycle. So that reservoir has to remain full, and the only way that happens is for water to return upstream. Okay. Now, there is essentially no air pollution or CO2 emissions from the process that creates electricity. Now, of course, concrete emits CO2, the production, the construction, all those things do have carbon footprints associated with them, but the actual water turbine generator does not produce any air pollution or CO2. All right. And also, so unlike maybe like a nuclear plant or a thermal plant, it takes upwards of 20 to 30 minutes for that thing to get hot enough to produce electricity. Dams are almost instantaneous. So you can kind of think of it as a giant low-tech battery, right? There when you need it. All right. And we don't really do this frequently yet, but we can also do hydropower in small scale. So maybe we don't construct a giant dam, right? And all we do is we take moving water, right? In this old water wheel concept that has enough energy to generate electricity, right? So there are ways, or maybe you just bypass the river and move water through sort of an artificial channel for electricity. There's all kinds of other ideas for like smaller scale. Now that would not be produce nearly as much power per generator as like a giant dam would, right? But this can be done without having some of these disadvantages, right? The primary disadvantage being, of course, that it's expensive to build dams, and probably the single biggest controversy around dams is the fact that they really have a major disruption on the river habitat, right? Makes it really difficult for migrating fish, for example, to do their thing, so that it impacts their population. So there's some disadvantages that are not air pollution, climate change related, that make dams really unpopular in certain parts of the world, okay? And of course, areas that don't have rivers can't use hydropower in this sense, all right? Now, moving on, we can look at tides, right? So hydropower is just simply the idea of using water to power things, right? So tides are very reliable, right? There's a predictable cycle of water moving in, water moving out based on the gravitational pull from both the sun and the moon, right? Very predictable. And so there's all kinds of ideas out there for taking this predictable pattern in our oceans and inlets and sounds and stuff like that, and using that moving water with the tides to spin turbines. So you can almost think of them as underwater wind turbine concept, but rather than wind blowing the turbine, it's water. There's several different concepts out there. One of them involves using waves. So basically, you have a buoy type structure anchored to the ocean floor, right? The ongoing up and down of waves could theoretically spin or move object within a generator to create an electrical field, right? So these are out there. They actually do work. The prototypes do produce electricity. But again, ocean water can be corrosive. How does this impact underwater habitats and so on? Those are ongoing studies. This probably will be something that scales up eventually, but it is something we can use hydropower for. All right, next topic, 6.10, geothermal energy. As the name implies, geo being earth, thermal being heat. We're going to take heat from within the earth and access that heat to generate things like electricity or heat water in homes. So basic idea, you have underwater, right? So we have superheated water that's in close contact to some sort of geothermal heat source, maybe a magma plume or something like that, right? We can drill into that super hot water. Now, hot water is pumped to the surface. Now, that water is under intense pressure under the surface. And so it's actually much, much hotter than just boiling water like we would have at the surface. So as that superheated water works its way to the surface, that pressure is relieved and it just creates steam, right? So then here we have our very familiar high pressure steam turbine system, all right? So the difference here is rather than at the surface burning coal or natural gas, right, or using a nuclear reactor to boil water to create steam and spin the steam turbine, right? We're taking already heated water that's been heated by interior of the earth, right? And once that reaches the surface and that pressure is relieved, right, that turns into steam, right? That steam spins the turbine, generator, and off we go, right? Now, the leftover steam goes into these cooling towers where it cools off and condenses back into liquid water, at which point that cooler water can be pumped right back into that underground water reservoir, where it will then be heated again by the interior of the earth, the processes that cause that to be hot, and we have a renewable system, right? So this is a pretty cool and unique way to operate a steam generator system. And what's also cool about this is the same steam, right, that's just coming over here to cool off again, right, can also be used to heat buildings and water, right? So in Iceland, for example, almost the entire city of Reykjavik gets all of its hot water, heating for the buildings, right, from their geothermal heating plants. In fact, all the little villages, every village has their own borehole. A huge percentage of the power, particularly for heating water, actually is generated through geothermal energy. Okay. And has very low CO2 emissions, not as low as solar or wind, because water that's underground exposed to heating rocks, right? The water itself actually contains some dissolved carbon dioxide. So we're actually having a little tiny bit of CO2 emissions coming out as that water cools, right? It is a minor fraction compared to what we would get from something like coal or natural gas, though. All right. Now, disadvantages, it's expensive, right? We're digging deep underground, right? And sometimes the steam is a little corrosive, right? So it's an expensive process. And of course, not everywhere has enough geothermal heat near the surface to make this even remotely practical. So even where it is near the surface is expensive. If we have to dig down super far, it's just not practical on the financial scale. Okay, so it's really only practical in certain areas. Iceland being right on top of a divergent boundary, of course, being one of those places. All right. Now, there is also some air pollution. If you've ever been around like hot springs or in volcanic areas, right, there's that characteristic kind of rotten egg smell, right? What you're getting from that is probably hydrogen sulfide, right? That is actually a somewhat toxic gas, and it could lead to acid rain anytime we're putting sulfur and stuff like that in the air. Okay, so now you're not at dangerous levels near hot springs, mind you, but you are getting whiffs of that. So we do get a little bit of hydrogen sulfide emitted as well. So it's not completely without air pollution. There's some, but compared to our fossil fuel resources, it's a minor fraction in terms of that. All right, hydrogen power, last topic. So hydrogen is a very unique fuel source, right? For several reasons, and we did bring this up in class. Okay, so we'll notice in this little diagram, right, that we're utilizing power sources like wind or solar or hydro or geothermal, right? The key here for using hydrogen power, part of its appeal is the fact that it doesn't produce carbon emissions, right? If we use fossil fuels to get that hydrogen, then obviously we lose any attractiveness that hydrogen would have. Okay, so we're utilizing other power sources to extract hydrogen from water, right? So hydrogen being the single most abundant element in the universe, super abundant on planet Earth, right? Except free hydrogen, just hydrogen gas, is actually really rare because it's so reactive. It doesn't stay by itself. It reacts with things and combines, usually into water. So most of the hydrogen is locked up in the water. Good news is we have so much water, right? And it's a renewable process, as we'll see here in a minute. So we use water to get the hydrogen, but after we've used the hydrogen, we make that same water again. So we're not going to run out of water, for example, by extracting hydrogen from it. Okay? Now, once that hydrogen has been extracted, right, it would typically be stored in a tank, just like any sort of like natural gas or propane would. Okay? And then that hydrogen gas can be used for all sorts of purposes. It can go to help make nitrogen-based fertilizers, to help with agriculture, right? It can be used as a flammable gas, although that's an unattractive way to use hydrogen, and we'll get to why that is in just a minute, right? So it can power large and smaller vehicles. Okay, so this would be an alternative to our traditional battery electric vehicle that seems to be winning in the markets right now. All right, but or it can be used to generate electricity, probably through fuel cell technology. Okay, so and it's an extremely versatile thing, similar to natural gas. Remember, we talked about how natural gas can be used to power vehicles. It can be used for transportation. It can be used for heating. It can be used for electricity production, and it is used for all those things. Hydrogen, very similar, so very versatile, etc. All right. So now, the ways in which we use hydrogen. Right, we could theoretically just be burned, right? But hydrogen, we burn natural gas and methane and propane and stuff like that. It creates this nice, pretty clean blue flame. Hydrogen also exceptionally clean, right? But also considerably more volatile in the burning process. Burns much faster and hotter and a little bit more explosively. All right. So the idea of burning hydrogen, right, particularly in transportation automobiles, is sort of unattractive for that reason. It's not that you couldn't power a vehicle off of hydrogen by burning it. It's just that we add a little additional risk to the process. All right. So more likely than not, if we go down the hydrogen fuel highway, we will utilize this idea of fuel cells, right? So fuel cells are a technology, and it's pretty cool in that we input hydrogen and oxygen, right? And rather than combusting those to make water, hydrogen and oxygen, if you burn hydrogen in the atmosphere, it will react with oxygen to make water, right? We create an electric current, right, by putting the hydrogen and oxygen into this fuel cell. So what we essentially do is we create an electric vehicle, but rather than running off our traditional lithium-ion batteries like most electric vehicles do today, right? This would operate off of pumping hydrogen and oxygen into a fuel cell to create that electric current. But then it's still an electric motor, right? Probably still going to be some battery backup in there. Okay, so hydrogen fuel cell cars are in fact electric cars, all right? But rather than like lithium-ion batteries, they use hydrogen fuel, oxygen from the atmosphere, and then fuel cells to create the electric current rather than batteries directly to an electric motor. Okay? So it's a pretty cool technology. But just like all of our sources, we have both advantages and disadvantages. All right? So hydrogen is renewable, right? We get it from water, and when we use it, we just create more water. So we have a closed loop there in terms of where the hydrogen comes from. All right? Zero air pollution, okay, or CO2 emissions. So when we burn hydrogen and oxygen, for example, or if we run it through a fuel cell, all we produce is pure water. It's beautiful. All right. It's 24/7. All right. So we talked about this in class, but again, I showed you guys in the initial diagram how we can use things like wind and solar or hydro or geothermal to create hydrogen or to extract hydrogen from water, right? Now, this is a way to store surplus solar and wind, right? So it's not that there's not enough solar and wind. You're going to hear me keep saying this, right? It's just that it's not always available where the turbines are or where the photovoltaic panels are, right? But we can produce surplus power when the wind is blowing and when the sun is shining. That surplus power theoretically could just, it doesn't get used, right? What we can do is when we have surplus, we split hydrogen off of oxygen from our water supply. Then we have hydrogen, which is essentially a way of storing that surplus power from solar and wind. All right. And then what's also attractive about that is big solar farms, which are required to produce very much power, and big wind turbines. Those are not portable. So they're only attractive for the idea of electricity generation, etc. Hydrogen is a portable power, getting us many of the advantages that natural gas has. All right. Now, disadvantages. What's the hang up? Why aren't we doing this? Just all we do is use water. It's renewable, right? We can store it. Here's a hang up. It's a negative net energy. And I believe at the beginning of this unit, I said if something does not produce more energy than we put into it, it's sort of not a good energy source. All right. So that seems like it would maybe make hydrogen an automatic non-starter. All right. So essentially, this process puts energy out, but to go from water to hydrogen and oxygen, we have to go energy in. Right? And if we're doing that process, the second law of thermodynamics tells us the energy in to the water, some of that is going to get lost, right, as heat in the process, right? Not to mention the fact that that's an endothermic process. Okay, but even after we burn the hydrogen, you get a lot of that energy back. There's some net loss. So we have negative net energy. So why would this be a non-starter? The reason is this, right? We have surplus clean energy at certain times of day during certain weather. All right. A lot of that energy we are not utilizing because it's surplus. We don't have any good way to store it. And so we can think of that as lost energy. Okay. So if we use that surplus, even though this is a negative net energy process, the lost energy here, at least some of it and much of it, is not lost because we can at least create hydrogen from it or extract hydrogen by utilizing that source. So we have lost energy here that gets used for nothing. We have some lost energy here, but at least some of it is stored in that hydrogen we extract from water. Okay, that's why even though it's a negative net energy process, it might still have some use for society. Plus, it helps with that intermittency issue. All right. Now, like many of our emerging technologies, right, fossil fuels are dirt cheap, right, comparatively. Fuel cells would not be expensive, by the way, to burn hydrogen. It is expensive, however, to make fuel cells. So to use hydrogen safely, right, and effectively, fuel cells contain platinum as a catalyst. All right, and as we all know, platinum is an expensive metal. Okay, so hydrogen does have some definite advantages, things that make it attractive. Those disadvantages are a hurdle, right? But we'll see where we land. Adios.